Okay, folks, I'm going to do a fairly quick video here just to supplement what we've done in class in case you need to go back and brush up on it. But being in class, of course, is hugely important. Can't emphasize that enough. Any quadratic equation will graph out as a parabola. That's what you see here below. You see here's the equation of the parabola, and here's the graph of the parabola. A parabola will have up to 4 critical points. Okay, you have a vertex. That would be this down here. You have a y-intercept. You will always have these two things, the vertex and the y-intercept. Okay, there's the y-intercept. And you also have solutions. But remember, sometimes you don't have solutions. And the most solutions you could have would be 2. So that's how you get up to 4 critical points. Solutions, remember, are the same thing as the x-intercepts. So that would be this and this. Okay. There's our parabola. Now, answer this question, find the y-intercept of the above equation. Obviously, that's right here, 0, -8. Find the x-intercepts. Well, we know that that's x equals -4 and x equals 2. What else do we want to do here? Through the vertex is this axis of symmetry. That creates a mirror image. If you folded this parabola over that green line, it would match up perfectly. The axis of symmetry is always going to be a vertical line. So that means the equation of it is always going to be x equals. And it's going to be x equals whatever the x value of this vertex is. Of course, that's going to be -1. Because the vertex was what? -1, -9. Okay. Now realize there's this point here kind of seems a little bit strange, but there's a mirror. You see how these solutions are 1, 2, 3 units away from the axis of symmetry on both sides. It's a mirror image, so if you wanted a 5th point, that would be right there. It's not called a critical point, but that's the mirror image to this y-intercept. Okay, I want you to realize, here we found these x-intercepts just from looking at the graph, which is really simple. But if you look at the original equation up top, to find the x-intercepts, we change the y to a 0 because every x-intercept has a y value of 0. And we would write the equation down. This is what we've been doing forever. We could factor this. I'm going to use 4 and 2. That's factored correctly. And you see how these things, sorry, this should say -4. You see how these things, God, what am I doing? Sorry, going a little bit too fast there. Obviously, to make this come out to 0, that should be a 2, and this should be a -4. And you see how these match these. Here, we just saw it from the graph, but if we didn't have the graph in front of us, we could easily find the solutions by doing quadratic formula or factoring. Okay? Excuse me. Find this. So here's another term, zeros. It's the same thing as x-intercepts or solutions. So there's actually 3 terms for the same thing. Okay? X-intercepts, solutions, zeros, they all mean the same thing. It's called zeros because the y would be 0. Again, just like we did a moment ago, we could factor this. And this would give us zeros of x equals -1 and x equals -3. Okay. Now a table if I have a table here, I want you to realize that we can build the y column of this table by taking each one of these and plugging in here. Watch this, -3, if I plug it in there, -3 squared is 9. 2 times -3 is -6. 9 minus 6 is 3. 3 minus 3 is 0. Okay. I could take -2. -2 squared is 4. -2 times 2 is -4. 4 minus 4 is 0. 0 minus 3 is -3. I could do that for every one of these. I'm not going to talk about every one, but if you wanted to do that, you could double check yourself. You should get these values. Okay. Now, if I didn't have this graph here, sorry, if I didn't have this, again, I don't know what I'm doing. I'm making mistakes here. That should be a 1. If I didn't have this equation here, if I was just looking at this table, I could immediately look here and say that my zeros are -3 and 1, because my zeros will always have a y value of 0. The x value is the actual solutions. Okay, so that's the solution, as is that. Remember, this is not a solution because this is the opposite. The x is 0. This is the y-intercept. All right, and then this is the vertex. You see how these numbers are getting smaller, 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 smaller. They bottom out at -4, and then it starts to go up the same way on the other side. So you see that where that bottom is, or if it's a top, that's the vertex. I'm going to plot these points. Watch this, -3, 0, -2, -3, -1, -4, 0, -3, 1, 0, 2, 5, and then this last one, 3, 12, would be about right there. Now notice how things look a little bit lopsided because I don't have all the points. I don't have like an equal number of points on each side. But there's the axis of symmetry because that has to go down through the vertex. Remember, it has to be a mirror image. You see how this point here is 1, 2, 3 units away from the axis of symmetry? Just count 3 more. 1, 2, 3. So there's another point. This one is 1, 2, 3, 4. So I count 1, 2, 3, 4. And now I have symmetrical dots. And there we go. Okay. So zeros, again, x-intercepts, solutions, zeros. These are all the same thing, okay? I could find it by doing some quadratic formula or factoring. Here I would get x equals -2, x equals 1/2. I could get a x-intercept from that's a fraction, that's okay. So that's from an equation. This next one's going to be from a table. So let's say I had these values, -4, -3, -2, -1, 0, 1, 2. And here, 5, 0, -3, -4, -3, 0, 5. If I saw that, I would just look, boom, my zeros would be -3 and 1 because that's where see here it says the x values when y is 0. So my solutions are x equals -3, x equals 1. Okay? And then, of course, if you had a graph, you would just look at it. It's really quick and painless. You know, if I had my calculator, sorry, my computer is wigging out. It'll come back in a moment. So if I had Now let's just say I gave you a graph like like this. Clearly, those are my solutions. So x equals -5, x equals -3. That would be the zeros. All right. So you should try to do this yourself on this. Pause this. Do this yourself right here. I'm going to talk through it quickly now. This one here, boom, I have disappearing ink here. But that would be x equals -2, x equals +4. Those are my zeros. Yeah, see the ink disappeared. Here in the table, -1, +3. Here I would do some factoring work. X and x, 8 and 4. I get x equals 4, x equals 8. Easy peasy. Down here, I got a match to the things in the bottom. So I'm going to do some, it's hard for me to show both of them at the same time, but I can do some factoring. Change the y to 0. There's no GCF here. X, 4, 1, plus. That gives me zeros of -4 and -1. Where do you have -4 and -1 down here? And you realize, see, that's -4 and that's -1. This is B. This one here, no GCF. I get x equals -1, x equals +4. And you see 1, 2, there's the +4, there's the -1. That's A. X, 4, 1, plus, minus. This would be x equals 1, x equals -4. There's the -4, there's the 1. That's C. This one here, this one doesn't factor, okay? There's no way you can do factor pairs of 1 that'll give you 1. You can use quad form. You will end up, I'm not going to show it here, you will end up with no solution because you end up with the square root of a negative number, which is impossible. So you go down and look at all the graph choices at the bottom of the page. Again, it's harder for me to, you see these ones down here, and you see no solution. That would be E. You see how the graph here at E, that doesn't go across the x-axis. Okay, whoops. So that one will be E. This is just more the same. 2, 2. You get x equals -2. That's G. This one here, remember, take out the GCF. X equals 0, x equals 2, H. So if you need to rewatch any parts, please do that. Okay. Hopefully that helps. See me if you got any questions.